Hello and welcome back to compiler programming. Let's continue working on our negation implementation. There is a few things already done, but there is a lot to be done still. And today I want to try to tackle this part, which is kind of a reflection. I think eventually this will be also a user-land, at least partially thing. But right now I'm just gonna implement it in the compiler so we can make progress. The idea here is, of course, that we have an operand type here. Let me show you. That is a bunch of things. And the idea that I have is to have a compile time function that would take a binding, and so some kind of reference, x for example in this case, or result, and it will turn that thing into a value with the type that is one of these. So we take a tagged union and we kind of extract the insides of it and use that for overloading so that we can get like the maximum out of the compiler ability to overload, and we, instead of kind of having to pattern match on this stuff inside the function, which requires way more functionality in the compiler. But also I don't want to do that because it will mean that we cannot easily add optimizations later on. Like extending a function that inside of itself switches on some value is basically impossible unless the function wants you to do it. But if we have the overloading on the values, it means that we can just add a new overload and everything is great. So that is the plan. How we gonna do it? That is an interesting question. I guess we need to have extra stuff created out of our generator here, this macro program. So I think what I will do is I will try to do the following. Type operand is this, and push type operand. That's this build. Okay, that's great. That means that I can now do some extra stuff on this thing. Okay, that's great. Let's try to figure out what it will be. Where is our... This is print type. Great. Let's create another function that would be print operand reflection. No, print reflection type, I guess. Tagged. Let's say print reflection type. And we are going to take all of these jazz. We're gonna copy it. In here, we will just say assert not implemented. The same thing here for now. And for tagged union, reflection, yeah. In here, we want to do stuff. So the union, I don't want that for now, so I will skip it. But I do want to have individual structs, and I also do not want the union struct just yet. Okay. So this is a bunch of not implemented. That's great. And let's see what we do here. So I guess we need to look at value.h, where we have a bunch of them already defined. Uh, yes. So this is what it would roughly look like. We would have an APEC type for each of the types inside the tagged union. So for example, if we take a look at this thing here, right? So for example, it's interesting to figure out what would be none and any because they don't have a size, and I haven't decided yet what to do with zero-sized types, how they should be handled in the language. But anyhow, let's take something more straightforward. So we have a register, right? And we have it. Now that I'm looking at this more closely, what I'm noticing is here we need to know the size of the register. And the size is coming from here. So what this means is I think I will have to define these types manually. So this was a bit premature. I will leave it as is, I guess. But actually, no. Let's get rid of it, and we will do it manually for now. If I figure out how to automate it later, I will do it. For now, though, let's do it here. How do we do this? Well, we need to be able to define some types. As value type. Yeah, I think I will take this and put it inside another macro and mass define a pack type. It will have a name, and yeah, it will have a bit size. So it will be exactly that, and here we'll just forward it. So mass define pack type, name, and the bit size. Okay, that still works. That's great. So this is descriptor. Okay, this is a type. It's not exactly what we want. Value type is okay. So let's try it out. Mass define a pack type. We want a bunch of them for registers of different sizes. So that would be register 8, and bit size is, in reality the bit size is actually 4 because this is not the value inside the register, this is the index of the register. But for now, since nothing really supports these non-byte size values, I will not do it that way. I will add a to do here and say to do shrink to 4 bits when supported. This is a separate task altogether to figure this out. So here we have 16, here we have 32, here we have 64. They're all this size. Let's try to build this, see if it works. It does work, so that's good. Let's continue looking at what things we need to have. Then I guess we have immediate, and here it's a bit more complicated because immediate actually needs to we are storing again the byte size and the pointer to where the immediate is actually located. So I don't know how we gonna handle it. I guess size of operand immediate reflection, something like that. We will actually introduce this. And it's a slice. Yeah, let's just turn it into a slice. That's okay. What else? Where's the operand? So again, none and any. I'm not sure how I'm gonna deal with them. E-flags is interesting. I guess E-flags and size of compare type. Maybe. I think there is actually operand E-flags like that. Yeah, this is really not great here that we have it as a common field instead of being inside of here. Oh well, okay, I'll have to deal with it. I think I will not support other things. I will just error on it for now, and even immediate and flags maybe not required, but it was good to think about how it will work. For now, I'll just focus on these four, which is exactly what we have here in the example. We define these things here, but we still need to define them in, or yeah, we still need to define them here inside of program init. Okay. Where is it? It's here. In the global scope, we need to define a value, and that value would be what exactly? Will be type register 8 value. Okay, register 8. I haven't decided on capitalization either, to be honest, right now. Maybe like this. Register 8 value. Does it build? It does. Okay. Register 16, register 32, and register 64. Okay. That is good. I think the next thing that we need to do is figure out a test for this. So I've actually recognized the test a bit and cleaned them up. So they are all now inside of some kind of sections. There also been 32 tests are separated from the rest. Okay, I think I will put this test for now in here, and it will also be one of these. Let's realize news convention. Yep, that sounds good. So we have result that is S64, and what I would want to return is the following. Operand, actually we'll call it operand variant of, and we'll save result. Or rather, let's do it like this. S64. And we are returning a register 64. Yeah, that seems reasonable. And the reason this relies on Windows calling convention is because I need to know what is the actual index of this register, and I know that it's supposed to be RCX. So in here, I can say that checker is, let's do it like this, register actual is this, register expected is, I already forgot how we are defining these registers. Do we even have them anymore? Everything is forgotten. I guess it's in here now. So yeah, it's called register C. Okay. Register C. Actual is expected, and let's provide a nice message if it fails. Expected percent. I think this is would be just D. Got percent %D, and I will say expected actual. Okay. That obviously is supposed to fail, but let's see what is the error in failure. Okay, and the reason I actually like to also run the tests, even if I know that fails, because it allows me to verify that compiler doesn't crash anymore. I've done a bunch of work on trying to make errors more to be handled better, and it seems to be paying off so far. So I haven't seen crashes that are not intentional in a while, and that's good. So yeah, we have undefined variable operand variant of. That's pretty good error message. It's not perfect, but it's pretty good. Okay, I know where to go for it, I guess. So we have parse expression. Parse expression actually handle dispatch operator. This is the thing that I want. Yeah. So in here, we can do else if the same thing here, and this would be operand variant of right? And we need to figure out how we're gonna deal with this. So this is basically the same handle operand variant of handle cast. Let's copy this out. That is quite a big function, but okay. Let's copy what we want and clean this up. Okay, what do we expect as an argument? But first of all, we expect only one argument. So if length of args is not this, then we need to say where is I need a way to report an error. Yeah. So another thing I did in between the videos is I finally made this better. Now it's a printf style function to print errors, so that's pretty nice. And we can say operand variant of expects a single argument. And we will say return 0. Okay. And source range is actually here. Source file. Yeah, okay. Now we can get the value. And what are we going to do with it? Well, we will need to turn it into a different value. So let's say switch on value operand tag, and we have operand tag nan break. So we'll do a bunch of them and just state that they are not supported. Operand tag nan any immediate e flags xmm. What else do we have here? XMM, memory indirect, SIB and label. Memory indirect, SIB and label. All of this is not supported, so we'll just say panic to do implement operand reflection for more types. Okay, and we say case operand tag register. Now we need to have another switch. We are switching on the size of the register, so this would be value operand byte size case 1 2 4 8 default. In default case, we of course will panic, and here it's an actual panic. Internal error unsupported ported register size. Okay. All of it somehow will need to be platform specific. So yeah, I'll need to figure out how to do how to make that happen, but we'll see. Okay. So we have these things. I don't think I need any of that, to be honest. And we can say value star result is 0. And say result is what? Well, actually, let's allocate the value. Allocate context allocator value. What is your value? Okay, for the descriptor, your descriptor is descriptor register 8. And operand is yeah, this is again where the way I store immediate operands right now is not great. Well, what can you do? I'll need to make that happen. Should I just create these somewhere here? So the problem right now is immediate operands, they need to point to some memory. And I see here like it points to something else. And I need to have register indexes. So I guess, how do I want to do this? Okay, whatever. I will actually allocate it. And say U8 register index is going to be allocator allocate feels a bit awkward to allocate one byte, but it's fine. I can clean it up later. To figure out better encoding for small immediates. Okay. Register index is value operand register index. And here I can say byte size is 1, and then immediate memory is register index, and tag is operand tag immediate. So actually I can move this over here and say operand result operand is this. Okay. Yeah. I can even do something like I guess this descriptor star result descriptor, and then Yeah, this would be just great. Then I can put this back directly into here. And just a regular sized dispatch. 16, 32, and 64. Okay, that feels fine. I'm not sure how well it works. Yeah, here I need ampersand. That's great. And here actually I need to have it like so. Byte size, brand, take immediate. Okay. Must have. Well, it's called byte size. I forgot the comma here. That's a very confusing error message. And finally, I'm missing a percent here. Okay. So, well, that is basically it if it works. We'll see. Let's try this out. Well, that didn't quite work. Expected one and got garbage. Okay, that is not great. Why did we get garbage? So we didn't crash. Let's see what this says. Okay, how's this called? Handle operand variant of. So let's break here and see what we have in the debugger. So we got the value, I get here, we get the register index. So let's check register index. RCX is 1, right? Yeah, so that's actually correct. So result, what do we have here? We have descriptor, that is this, that makes sense. Bit size is 8. We have operand tag immediate, which is 1. Yeah, and here if we look, yeah, so here's the memory. We add to watch and we cast that to char star, and we have 1. So everything seems fine here. Let's step through. We have result token. Everything is great. I mean, seems good. The question is, why doesn't it work? I can go into here and I guess make another breakpoint here, and I will step into disassembly and see what actually happens there. Call, Yeah. Oh, I know what the problem is. The issue is that register is, yeah, yeah. So uh, here I got incorrect type. That is actually the problem in the test and not the problem in anything else. No, that's the wrong test. This is the right test. S8 and S8. Okay, that seems great. And now I believe if we run the test, everything should be a-okay. And it is. Great. So basically, that's all I wanted to do for today. We can check off this uh, point, at least for registers. There's obviously way more to do with other type, but it's again more of the same. Defining a type in here, actually in here, and then defining a type in here, and then piping it all inside of this dispatch. So it's more or less the same work. Register is just the easiest one of them, but all the others are not too hard either, except for the whole situation with byte size. But I will think about it offline and think how we gonna handle that. Yeah, but this is good progress towards the negation support. Hopefully in 1 or 2 videos we will be able to wrap this up and have a very nice way to define new operators and new things without doing so in the compiler. For today, thank you very much for watching and hopefully see you next time.